afternoon, everybody. Today, I'll be presenting the research work that I have been working over the last 7 years. The background of my work is that I have been really active in solar activity prediction as well as natural disaster. I've been doing such work continuously for 7 years. And I have discovered a lot of connections between solar activities and Earth changes. And of course, found some connection with electricity and electric universe. And I would like to present this work to you today. So first thing first, the objective of this talk is going to be providing some insight into global natural disaster forecasting technique. Second is to utilize property of space and planets in explaining the current of natural disaster. And third is to explain the interaction between solar activities, planetary alignment, and how this can lead to natural disaster on Earth. So many of the things, such as planetary alignment, it's an observation that so many observers around the world have seen to be some connection, but it's really hard to explain how does it work. So I will be presenting some of the scientific experiment to help verify that this can be true, through science. So next we start with the word forecast. Forecast is about, from definition, is to predict or estimate. We want to know something in the future. And in order for someone to know something in the future, such as how each person come to this conference, of course, we have to done this type of things before. So it relies a lot of experience, practice. We actually need to know the destination where we are going and what kind of tools we are going to use and implement and actually take the efforts to do it. And of course, nobody learned how to walk since we are born. We actually need to practice. So we actually need to spend a lot of time to develop the skill to do this. So in order for someone to make a successful forecast, we start with looking of the subject of interest just the way it is and see what are the things that we can learn about the relationships of the two things. So first, I would like to use the picture from David Somerville and Hugh McLeod about how we actually obtain some understanding of something. So we start with data. So it's a collection of informations, and we catalog it in a way that we can make some relationship between different data. And of course, require knowledge, or in this case, we're looking for scientific knowledge to help connecting all the data, understand how each type of data or information is linked to the others. And it requires insight. Of course, we have to know where we're going. So that's very important in terms of doing the forecast. So it provides, we have to have insight that there is a path toward the goal. And of course, to accomplish all this, we have to put in efforts. So we call this a wisdom, is the choosing the right path, using the right tools, and spend efforts to make it work. And of course, the path we choose, we want to choose the shortest path. And of course, to use the tools, there are so many different tools. we want to use the tools that's the most effective. And the most effective tools in nature, we call this the law of nature, because these type of tools never change over time, unlike some scientific theories, which is based on some certain perception. It may change if we change perceptions. So in this case, we look into the ultimate law of nature, which several philosophies around the world has discovered and make the ultimate conclusions that everything that occurs in this universe happens for a reason, and that's dependent upon many things. So that means one thing cannot exist without relying on some other things to exist. And not only that, when it exists, it never lasts forever. It goes away as the factors that try to sustain its existence goes away. So the other tools I'm planning to use is, of course, the law of physics. And of course, in this conference, we talk about electric universe. So we'll be using the electrical theory to help explain a lot of natural disaster phenomena. And of course, we'll use electric to explain the Earth's interaction in local environment. And in addition to that, we also rely on wave properties to help explain things in a little bit more macroscopic. Model. So I propose to use the term quantum vibrations to explain the solar system scale interaction. And I will go over the word quantum in the future because why we want to use this word. So next, we're going to how we do the natural disaster forecast. Of course, just like everyone's here come to this room, or Suzanne and David Tubbo set up this conference. Of course, first thing is it has to be important. Otherwise, you're not going to do it. So that means the significance is one of the factors we use in natural disaster forecasts. And of course, once we know it's important, we're going to say when are we going to do it? So that's timing. And of course, the last thing is where, which is right now in this hotel room. So the same thing for natural disaster forecast. We're looking for, once it's significance, we want to look at the timing, which is the initialization of the events, and of course, the occurrence of the events. In terms of significance, we emphasize on high damage, meaning it could have impact to human infrastructures. If it's something that happened in regular basis or considered really normal, then it's no point to do it. And the last but not least is location, which of course will be specific to different type or different zones on Earth. But this presentation, I'll be focusing on the two factors here, is the significance and the timing. And the location will be a subject beyond this talk. So next, we want to implement the basic understanding of electricity and apply it to natural disaster forecasts. So the simplest way to look at natural disaster is, of course, it has to happen with a reason, and it needs some energy accumulation to happen before something can occur. So we look at electric energy accumulation in this case. The simplest model you can understand is a capacitor or a battery. It's pretty much when you have a capacitor or a battery, there's a polarization, so there's a charge separation. And when it's charge separation, there's always some stress that's building up in that volume of energy. Next, when charge is building up to some certain point, it starts to have some sign. For example, when capacitors start to break down, it starts to producing some noise or some kind of a vibrations, and that's when it's reaching some threshold. So in terms of natural disaster, such as earthquakes or volcanic eruptions or tornadoes formations, there's a threshold. And there are signs such as radioactive emission, such as there's a radon gas emission that emits out near the earthquake preparation zone. There's a mechanical movement. We can actually see the cloud that actually looks like cloud ripple. So people call that earthquake cloud. And of course, there are other types like thermal or electromagnetic radiations. So these are a warning sign of natural disaster in this case. So we can understand this through understanding of electricity. And of course, the last stage is the energy release. So when energy release from a volume, of course, it's come to different forms. If it's released in the atmosphere, we call that flash floods, storm, rain, tornadoes, hurricanes. If energy is released underground, we call that earthquakes. So many scientists have discovered a lot of electrical discharge underground when earthquakes occur, as well as above the ground. So next, we're going to talk about what helps energize these things. So there are many different factors. One is the external factors, which is space, surrounding space. The other is internal factors. But internal factors are very difficult to find data. So in this case, we more focus on the external factors, which is space and solar activities. So one of this slide here shows the sun, which on this side, left-hand side, producing coronal mass ejection. You see carefully, you see a big globe of plasma, see the Venus. As it reaches Venus, you see how it energizes the surrounding of the planet. And you might start to see some of the tail right here. There you go. And there's also a fluctuation of solar wind. So during the time when there are solar activities, such as fluctuation in solar wind, coronal mass ejection, there always something happen to the atmosphere of the Earth. And next, if you want to study the interaction between the surrounding plasma and the Earth, we have to conduct an experiment. One of the simple experiments that I've done at home, which is really simple, it consists of a vacuum chamber, and then it's connected to a pipe containing pressure gauge, pressure valve, and vacuum pump. And of course, we use battery, which generate power for the high frequency AC generator. We can also use DC generator, and it's connected to a magnetic sphere at the center of the vacuum chamber. So when we apply high voltage into it, you start to see plasma glow, which is right here. And of course, it starts to glow, and the place that is actually glow brightness is around the pole. We may look at this as some kind of aura events. And of course, what happens when you have external factor come into play? So this is very simple experiment. All you do is just put your hand close to the chamber, which provides a place where there's high conductivities that can seed plasma. So what happened when we do that again? So this is what happened. You see, there's plasma connected to the hand right here. And there's two form of brightness occur around the equator, in addition to the energy that goes to the pole. So that means it suggests that when we have a solar activity events, it actually impacts every places around the world. So that energy goes into the atmosphere. So this is in case where there's a CME events coming and reach the Earth. So another clue is if you look into the satellite image, like this one, we see the total electron density, the electron number density at 400 kilometers above the Earth. We see two strips of high plasma density, just like we see from this experiment. So next, we go into more details about how we do the forecast. So it relates how plasma density play an important role in modulating the atmospheric energy. So we can do some type of prediction, a simple one to begin with. So let's start with the sun. If we look in the sun, there's a period where there's low number of sunspots, and there's a period where it's high number of sunspots. So the difference is plasma density. That's one aspect of it. So if you look in the ionosphere, so when there's a lot of sprites occur, that's the time when space contains a lot of plasma. And next step, if you go down toward the atmosphere, you just look at the sky. A simple observation: when the sky is clear, there are less plasma concentrations. And as we move towards more clouds and it becomes more condensed, you start to see more electricity, plasma discharge, or tornadoes formation. We can call that Bergman current as well. So in this case, we have the time period with low plasma density and high plasma density. And they actually highly linked to the sun. And when we talk about the low sunspot number and high sunspot number, this is not only include the 11-year cycle, but all the subcycles, which have been changing very rapidly, like within a few days, from low activities to high activities. So how do we relate this to natural disaster, or how we link this to electricity? So when the sky is clear, you have strong electric field. So there's not a lot of current that's going on in the sky. And during the time when there's a lot of lightning and thunderstorm, we see strong magnetic fields. So we see power transfer and dissipation. So if we want to predict a natural disaster, such as when the storm to start to occur, we look at the precursor, which is the sky look just like this, where we see how clouds build up from light cloud to really dense cloud. And this is a global event. That means it happened around the world. However, there are some places that this type of events occur more noticeable than the other area, but it's a common observation. And of course, how are you going to predict earthquakes? It's the opposite. So you're looking at the time during the period where charge have an opportunity to build up. So that means during the strong electric field. So when we want to predict earthquakes, I'm talking about really large earthquakes. Typically occur when the sky is clear, no rains, less humidity, very dry, and of course could be strong wind, because E-field can produce ionic winds, which are causing sudden disruptions in the weather, but in terms of just wind, but not the moisture content perspective. Or in the other condition is when the sunspot reach its peak and is in the decline phase. So this is how we use electricity to help understand how to predict natural disaster. So let's go into case study last year and this year. So last year, one of the biggest hurricanes that occurred is Hurricane Jacqueline, which happened in September 2015. If we start the events with a lot of soil activities and CMEs, you start to see that the storm start to form on the September 27, which happened after one of the coronal mass ejection events. And next we have one of the largest solar flares of the year. This is M7 solar flares. And if you look at the sky at that time, you start to see how the clouds start to accumulate globally. So after that, second CMEs, which help accelerate the storm wind. And in addition to that, we have extra X-ray. And last but not least, the last CMEs happened on the September 30, which helped energize the storm for the last time before it decayed. And of course, new storm formed on that day. So another case study. So this is when there's a sunspot peak and there's a peak in solar activities. During the time when there's low solar activities, in this case is the Chilean earthquakes happened on September 16. And during this time, as you can see, the sunspot going to the period of decline phase, 116 days. It reached a convergent point at this day before it's shooting back up. So there's actually a disruption in energy cycle over a 2-month period or more. And of course, there's trigger events happen, and 4 days later, we have M8.3 earthquakes. So I have discovered this pattern and have published this work in the New Concept of Global Tectonic journal last year. So you can see the reference here. And of course, it happened with another warning sign from space, which we call that planetary alignment. And we will talk about that very soon. And another popular observation that people have been adopted around the world is looking at how the coronal hole, which is the black spot, like this, as it moves and rotates and aligns with the Earth. The problem with this observation, from my perspective, is that it happens so frequent. For example, like every 3 to 5 days, so it's pretty difficult to use for predicting the earthquakes without using other type of factors. But again, I'm not an expert in doing coronal hole observations, so that's what I saw so far. And not only that, we see the dualities between strong and large earthquakes. So during a time when there's a lot of storm, in this case, we see on September 5th, 2015, there are 5 tropical storms exist on Earth at the same time. And right before the earthquake occurred, all of these storms just disappear. So there's some kind of energy exchange between atmosphere and underground, just right before large earthquake. There are also some type of earthquakes that occur around the peak of the storm as well, but it's not as intense. So another case study which just happened recently, Japan and Ecuador earthquake that happened in April 15 to 16, 2016. You see the same pattern that is repeated again here, that you see about 8 weeks period of decline before convergent back. And of course, there's a trigger point right about 3 days after a big earthquake. So we can actually predict these things as we understand how the sunspot patterns work and how the energy cycle of the sun works. And same thing if someone wants to look at the coronal holes, that's how this black spot here start to align on April 15th. So next, just look at how we can predict earthquakes and storm altogether, especially earthquakes. You see, this is a plot of global wind speed of all the storm combined on each particular day. So you can see that the y-axis here is wind speed in knots, and the x-axis is the date. If you want to predict the earthquakes, you look in the zone where there's no storm, or just the storm just dies down. So there's 2 periods here, and we see that the earthquake occur in that time period. One is the Taiwan earthquakes, magnitude of 6.4, and the other is magnitude of 7.8 in Indonesia. So now we move to a more system level scale. So now we understand that how the energy exchange between space, atmosphere, and underground. Now we go to a solar system scale because we want to predict how the space weather fluctuates far in advance. So now we're going to the quantum vibration theories. In this theories, we use the term quantum because it's the minimum amount of any physical entities involved in any interaction. If we look at Earth as a fine dust in space, so this qualifies as a quantum. It's something really tiny. A natural disaster, even though it occurs and looks really, big in human, for a single human, it's completely almost negligible in solar system. So the quantum vibration is pretty much the vibration, a little bit, just enough to produce noticeable interaction by us. So we use us as a sensor. So I just want to introduce a little bit of concept here, which I have spoken in the last Electric Universe conference, which is about resonant coupling in the solar system. And in this theory, we treat the solar system as a resonant system where the sun is the center of the vibrations, and of course, Earth approximately sit in the third harmonics of this vibration. And there's a lot of evidence suggests that such type of wave travel at the speed of light, but there could be other types of wave as well. It's like plasma wave. And of course, the frequency is calculated to be around 3 millihertz based on the distance and the velocity of light. And of course, we can see that how we can reproduce orbital plane, which will resemble the protoplanetary disk here, as well as our solar system. So we want to extend this theory into how we're going to predict the solar activities or some space weather fluctuation around the Earth far in advance. Another thing I want you to notice about Jupiter orbits here. If you notice, there are two lumps here of asteroid, and we will try to create an experiment that reproduce such type of separations. Next. So now we move on to planetary and space interaction. And of course, this is one possible explanation of planetary alignment phenomena. So we used the Clany plate, which consists of acrylic disc, and of course we put grain of salt on top. And you can see that when we put energy apply, it starts to organize itself into a ring. And as we change the frequency, you see how things evolve over time. And of course, in this case, we use the frequency of 1049 hertz, which is at the resonant peak of this structure. Diameter plate is 11 inch if someone wants to reproduce it. So it's producing 4 rings. Now, we're going to introduce boundary conditions, which are planets. So in this case, I mimic planet as some magnetic ball just put on top and the bottom of this plate, so they secure each other's. So one planet doesn't do much. So we turn from this observation, we see that a system that unorganized, when we apply vibrations, it becomes organized. And of course, we now start to introduce planet into as one of the boundary conditions. So what happens if you put more planets or a dot into a system? So that's one planet. Now we go into 2 planets. You start to see that the local space environment start to change as more object is introduced into the system. And not only that, when it sits at the right location, you start to see how energy got condensed or scattered. So this really resembled a Bohr atomic model, where there's a standing wave occur around the orbital path of an atom, or So for 2 planets, when 2 planets are aligned, of course, it starts to form a symmetrical shape. And when the planets are strategically placed at some certain stable spot, you see how energy got condensed. And when it's placed at other place, it gets scattered. So now we not only have 2 planets, we've got multiple planets on this solar system, so we want to go do some more experiment here. So in this case, we look at how we modulate the frequency. As we modulate the frequency, we can start to see that the energy start to change, but the boundary conditions around the energy around the planets remain about the same. So this is only a fractional change by about 0.6% of the frequency. So when we have solar eruptions, it's expected that the helioseismic activity at the sun is changing at that time. So you start to see that it's not only the space surrounding where the coronal mass ejection occur is going to change, but everything in the solar system change altogether. So next. Now we're going to 3 planets. So this is going to be more interesting, that we're going to start to see something even more fine. So this is when we have 3 planets align each other. And then it moves as it moves away. Okay, so see, the more planets that come into alignment, the more condensed energy it's become. And if you notice here, right, there's 2 lumps of particles that actually form around the planet. But I believe this is resembled how the particles form, the asteroid, clump together around the Jupiter orbit, which split equally distant from Jupiter. And this is when it's misaligned. Now, completely misaligned, but 2 remain in alignment. So next experiment is we're going to do more. We put more boundary conditions in, and you start to see how it works. So just keep moving. Now we're gonna misalign everything. So now we move Venus out of the orbit. It still have some symmetry in it. Now we're gonna move everything out. So all the energy is scattered. So now everything's all over the place. As you can see, if you assume Earth is the 3rd planet here, what happened on the outer planet does not have much influence on the energy of the inner ones. So that's when planets are aligned, 4 of them. That's 3. And of course, it just moving out, see, like the 4th planet doesn't really have a lot of impact. So next is when it's aligned and not aligned at all. So we can start to see how so many people have been using planets to do the prediction. And I believe this is the reason. Because during that time, there's a lot of things that fluctuate more frequent than other times. So next, we look into more evidence of this resonance. So we look into the harmonic resonance of the solar system. We should be able to see such harmonics occur on the planet level. And the best place to look at it is at the pole area. And at the pole, you can see dualities. There's a black spot on the North Pole of Mercury. There's a white spot on the South Pole, so that there's a temperature difference. So in Venus, so that's 1. The 2nd planet, you got 2. 2 vortices. 1 in the North Pole, 2 in the North Poles, and 2 on the South, which have like an infinite shape. And of course on Earth, it's very hard to see, so we look at the wind system. On the South Pole and North Pole, you look at the wind map, there are kind of roughly 3 vertices occur. And it actually coincides with one of the research by Bruce Lebon, who have proposed how the energy coupling from space for the Earth as a Y and delta transformer, which consists of 3 nodes. And of course, if you look in if you guess what happened on Mars, you should see 4 vertices around the pole, and that's, you see about like rectangular shape. And on the South Pole, now all the ice kind of start to vanish. You see there's less ice on the center. And the Jupiter, we're not quite sure. But of course, it's a popular one, which is the Saturn. We got 6, the hexagonal shape at the pole. So there's a lot of evidence of resonant vibration occur in the solar system, and we can actually use it for solar activity predictions, climate predictions. So, and these are reference for researchers that have been doing some predictions, such as sunspot formation. The graph on your left-hand side, you can see that they use planetary alignment to predict sunspot formations over multiple solar cycles. But there's irregular cycles and regular cycles, so there are many details on that. Also, John Nelson have used this to predict radio propagation each day. And of course, there are people who do a lot of prediction for earthquakes. Of course, last but not least, one of the last experiment, case study here. It's a case study of Indian Ocean earthquake happened on June 2010. And of course, there are solar activity during the time when planets are aligned. So in this case, you see multiple planets aligned in the center, in the same plane. And Earth is 90 degrees from that alignment. So you see how sunspot peak up during the time when planets come into alignment. And of course, there's an earthquake happen, magnitude of 7.5, and it's followed by another earthquake, magnitude of 7.0, which is about 3 days happen afterwards, which I already explained this connections in my last presentation. And of course, there are coronal holes alignments that you can use to do the forecast. And of course, this concludes my talk, and we have proposed a natural disaster forecasting techniques here, and it's based on electrical and quantum vibration theories. And I try to verify these theories through my own observations as well as other people's observation, and we built laboratory experiment to confirm that this actually can help explain some mystery that has been going on over the last few hundred years. So this concludes my talk, and thank you everyone for listening.